is the first in a series of videos about dimensional analysis, often referred to as unit conversions. The supporting topics that you'll want to be familiar with are how to determine significant figures in a measurement, and then also what is the metric system and what are units, so that when you see me using units, you don't say, oh my gosh, what's she doing? So we start with unit definitions, and you have probably already had experience with these because you might know, for instance, that there are 12 eggs in 1 dozen, or that there are 12 inches in 1 foot. Here I've noted that we can recall that there's 3 feet in 1 yard, and this is from the English system of measurements. And also here I have listed 100 centimeters equals 1 meter. This is the metric system of units. Both of these are definitions, and so we can take them and write them as fractions, because essentially they're just another way of saying 1. So I can say 3 feet over 1 yard, or I can say 1 yard over 3 feet. So if I was given a measurement, like let's say I had 5 feet, and I wanted to know how many yards that was, I would look at both of these choices and see, well, if I want to find yards, then I have to cancel out the feet. So the feet has to go on the bottom of my fraction. So I put 3 feet here because I want this unit and this unit down here in the bottom of the fraction to match. Because if you think about multiplying this all together, we know that we're dividing feet by feet and that those units will cancel out. The other part of the conversion is that 3 feet is equal to 1 yard. And I have to write that whole thing. I can't just take part of it. And so what we would do here is take 5 and divide by 3. And I get 1.667, which is a lot of 7s, which is really, given I only have one significant figure here, this is 2 yards. I could also do the same thing with my 100 centimeters. So I could say 100 centimeters over 1 meter, or I could say 1 meter over 100 centimeters. It just depends on what the question is asking me. So if I had, let's say, 2 meters, and I wanted to know how many centimeters that was, I would start with my measurement, start with the number I'm given and its unit, which is 2 meters, and then set up my dimensional analysis where here's meters up here, so meters must be down here. And I look here for which conversion has meters in the bottom of the fraction, and it's this one. So 1 meter goes in the bottom of the fraction, and 100 centimeters goes in the top. And when I do that, my meters cancel out, and I end up with 200 centimeters as my answer. So let's look at another problem. Here we have how many grams are contained in 300 centigrams. That's what that C stands for. You're probably more familiar with it in centimeters, but we're recalling that, hey, this is the metric system. Centa always means 100 parts of some whole. So I know from memorizing my metric system units, and you may as well already, or you may be in the process of doing that, that 100 centigrams equals 1 gram. So the question asks me to figure out grams, and it gives me centigrams. So I'm going to start with the unit and the measurement that I'm given. There are my 300 centigrams. I know this conversion, and I also know that if centigrams is up here, then centigrams also has to be down here. So I check this and see where's my centigrams. It's right here. So 100 centigrams goes in the bottom of my unit conversion, and then I have to finish it out with the rest of it, which is equal to 1 gram. You can think about this as 300 centigrams times 1 gram divided by 100 centigrams. The centigrams cancel each other out, and I'm left with grams as my unit. Sometimes people also like to write the measurement that they've been given, this 300 centigrams, over 1, because that makes it clear to them, oh yeah, I'm not putting anything else down there. So that may be a placeholder that you want to use. Now, some of you are looking at this and saying, well, I can do that using a ratio. I can say 300 centigrams is to 100 centigrams over 1 gram, but I don't know what X is. And you're really comfortable solving that. That's fantastic. That means you've got a good idea of how to do unit conversions. The problem that you're going to run into is if you don't adapt this thinking to this thinking, you're going to have a little trouble when we get to these problems and they're 5 or 6 conversions long, because that's a lot of keeping track of where your ratios are. I think that it can definitely be done. I haven't had a student successfully do that. So I would advise you to say, okay, I'm really comfortable with this and I can use it to check my work, and I'm going to try it this way. Because long term, this is a skill you want to develop. So what if you have to use more than one conversion? What if there's not a nice little conversion that relates the unit that you have to the unit you want? Well, right here, I've listed some common conversions that you run into in the English system. You don't need to memorize these. I've asked you to memorize some from the metric system. It's listed on the things to memorize sheet that I've given you. Probably posted it somewhere for you to access. These conversions are, hey, here they are. It's a resource. If I was doing an assessment that required one of these, I would give you these as an option. So let's attack this problem. It asks me how many milligrams are present in this number of pounds. And when I look over here, I don't see a relationship between milligrams and pounds. I do see a relationship between grams and pounds. And using my metric system knowledge, I also know that there are 1,000 milligrams in 1 gram. So if you haven't memorized that yet, that's okay. You'll want to do it eventually before your assessment. But for right now, it might be useful to have those metric system conversions available to you, so when you're doing these problems, you can get the whole process. So I'm going to start with the measurement that I was given, which is 0.0, oh my goodness. My screen has decided to be not pleasant to me. Oops, and now it's really not. Oh, there we go. So I've got 0.0353 pounds. And I see that, hey, here's pounds. So 1.00 pounds there, well, just pound, not pounds, is equal to 454 grams. Again, making sure that this unit and this unit are the same unit so that they cancel each other out when I do my math. That canceling helps me to focus too on the fact that now the unit that I'm interested in is grams. And so I can use my second conversion, that there is 1 gram in 1,000 milligrams, cancel out those grams, left with milligrams, which is what I wanted, and that lets me know I'm done with the problem. I still have to put it into my calculator and do the math, but I've shown my steps here, and I've shown my process, which is pretty important when you get to an assessment and you're communicating to someone about what you know. It's important to show your work, both because it helps someone to follow your thought process, and they don't have to try and fill in the gaps, which, by the way, we don't do. And secondly, if you get one of these steps wrong, you could get partial credit for getting the other step right. So I'm going to just plug this into my calculator, and I get this answer, 16026.2, and that's milligrams. Now I need to check my significant figures, and I see up here I had 3 significant figures, and here would be a significant figure, and here would be a significant figure, but I run into a problem right here, because if I leave that as a 0 and I drop my decimal point, I won't have enough significant figures. That would be 16000. It's big enough, but it's only 2 sig figs. If I keep that decimal point, 16000, now I have too many significant figures. So this number, I actually have to write in scientific notation to convey the correct number of significant figures. And I'm going to do that right over here where I have a little more space. Let's do it in blue. So I have to say 1.60 times 10 And I'm just going to count 1, 2, 3, 4 times 10 to the 4th milligrams. And there's my answer. And it looks like I have to go forward manually, which is okay. So here's the second example, or excuse me, a third example. Are we on number 3? Yes. So how many gallons are present in this number of deciliters? So I have 82000 deciliters, and I want to go to gallons. So I know from my metric system conversions that 10 deciliters equals 1 liter. And I know from our common conversions that 0.265 gallons equals 1 liter. So I've got my deciliters, and I want deciliters down here so that my units match and cancel out, just like that. And 1 liter goes on the top here, which tells me now I'm in liters, and now I have to get from liters into gallons. So 1 liter goes down here, so these guys cancel. And 0.265 gallons goes right there. And when you put that into your calculator, 82000, we're dividing by 10, and we're multiplying by 0.265. I get 2173, and only 2 sig figs in my measurement. So I need this sig fig, and I need this sig fig. This number is going to change to a 0, but it's greater than 5, so that means I have to round up. And there's my answer.